All right, welcome to The Explainer. Today, we're diving into a really pivotal debate about the future of physics. We're talking about a debate that basically puts the entire field on trial for a 50-year stalemate. And the big question at the heart of it is this: has our search for the fundamental laws of the universe gone completely off the rails?
So just listen to this charge from the debate itself. It's a heavy one. They're saying modern physics is the victim. And the accusation? That for, half a century, the entire field has been investigating the wrong suspects with the wrong tools. Billions of dollars have been spent chasing ideas that are, well, beautiful maybe, but ultimately fruitless.
So to really get what this trial is all about, we have to start with the indictment. It was brought forward by the prosecution's, you could say, star witness, physicist Sabine Hassenfelder. She's the one who's basically laid out the entire case against the last 50 years of so-called progress in physics.
And her argument is, well, it's devastatingly simple. She says that ever since the Standard Model was basically wrapped up in the 1970s, we found absolutely nothing. No new fundamental physics. She argues the entire field is just stuck in a loop, chasing what she calls mathematical fiction instead of, actual reality.
And this is where her critique gets really interesting, because it breaks down into two totally different ways of doing science. So on one side, you have good physics. Think of Einstein, right? He was trying to solve a real, actual contradiction in the science of his day. But then on the other side, you have what she calls bad physics, chasing theories like supersymmetry just to satisfy this craving for, well, prettier equations.
And this is exactly the method she says is failing us. You know how it goes. Physicists see a number in an equation they think is ugly. So what do? They invent 100 new invisible particles to fix it. And then when experiments at the LHC find nothing, they just move the goalposts. They say, oh, well, the particles must just be heavier than we thought. It's a game you can never really lose, but maybe you can never really win either.
So, look, Hassenfelder's diagnosis is pretty clear, right? The field has a problem. But this is the real pivot point of the entire debate. Because, hey, it's one thing to identify the problem, but is there a credible solution? Is there actually a different path forward?
And here's where things get really constructive. See, the debate didn't just stop at complaining about the problem, it actually presented a potential answer. And we're not talking about a small tweak to the old system. We're talking about building a radically new one, completely from the ground up.
So what is it? It's a completely different framework called the Bundy Reciprocal System Theory, or BRST for short. And look, it makes a massive claim that it's the only truly new system of physics since Newton. Why? Because it completely throws out the most basic idea we all have, that the universe is made of things happening inside some kind of container. Now, BRST argues that the big internal inconsistency that Hassenfelder says we need to find, well, it isn't in some specific equation. It's in our entire coordinate system. It's like trying to describe a fluid dynamic dance using an old static rigid ruler. The theory says that all that weird jitter we see in quantum mechanics, that's not a feature of reality. It's a bug in our system for measuring it. All right, so let's dive into how this actually works, because this is where things get, well, pretty mind-bending. How on earth do you build a whole universe not from particles, not from strings, but from just pure motion? Well, unlike other theories that need, dozens of constants and particles just to get started, BRST claims to start from absolute zero. First, you just assume one single thing, this constant eternal outward progression they call the monad. Then you introduce a reference point to measure it against, the dyad. And from just that one single relationship, two fundamental types of motion, these reciprocal ratios, they just logically have to pop out. And this two-clock analogy is a really great way to get your head around these two ratios. So imagine one clock, the SUDR. This represents matter. Its location in space just oscillates, tick-tock, while its time progresses forward in a straight line. But then you have the second clock, the 2DR, which is like light. Its location in space progresses forward, but its time is what oscillates, tick-tock. But okay, this is where the theory hits its biggest conceptual hurdle, and it was voiced perfectly by the skeptic in the debate. Oscillating time? Come on, that flies in the face of literally every experience we've ever had. Time just marches forward. Remember, Hassenfelder demands that physics be based on observation, and this feels like the complete opposite of that.
But here's the answer from BRST. You don't see the oscillation of time directly, not with a stopwatch anyway. You see its effect. All that weirdness, all that jitter and probability that we see in quantum mechanics, the theory says that's not some deep, spooky mystery. It is the observable effect of this underlying mechanical process.
And get this new perspective totally changes how physics thinks about, well, nothingness. In standard physics, you have a +1 and a -1, and they cancel out to 0, a void, a vacuum. But in BRST, they don't cancel to 0. They create a balanced system that's full of activity. The vacuum isn't empty, it's like a perfectly balanced engine, which actually explains that zero-point energy that we know exists.
So, okay, this is a pretty elegant and, yeah, a very different picture of how the universe works. But does it actually pass Hassenfelder's ultimate test? Does this new system actually solve old problems better than the one we've already got?
Well, let's take a look at gravity. The standard model, right? It has to invent a whole new particle, the graviton, to explain it. Einstein said space itself is curved. But BRST proposes something much, much simpler. It says gravity isn't a force or curved space. It's just the necessary inward scalar motion that has to exist to balance the universe's eternal outward expansion. It's not some extra thing you have to add on. It's just the other half of the cosmic equation.
And this is really the ultimate pest right here. Supporters of BRST argue that unlike all those pretty theories Hassenfelder criticizes, this system actually makes specific, testable predictions. We're talking about calculating interatomic distances from pure theory, deriving the periodic table from scratch, and it does all of this with just one fundamental constant, compared to the dozens that the standard model needs.
So you gotta be asking yourself, if this system has so much promise, why isn't it being debated in every single physics department on the planet? Well, the debaters suggested the answer lies in the exact same sociology of science that Hassenfelder herself criticizes so fiercely. It's kind of an echo chamber.
Here's the argument. BRST is being ignored not because it's wrong, but because it requires a complete unlearning of a 300-year-old framework. I mean, it's just way easier to get funding and get tenure if you write a paper that makes some tiny little tweak to a theory everyone already knows. Proposing a system that requires physicists to unlearn the basic idea of a space-time container, that's basically career suicide. The whole incentive structure, it's built for production, not for revolution.
So in the end, the debate doesn't really conclude with a clear winner. It concludes with this incredibly profound question for all of us. You see, Hassenfelder correctly identified the disease and what we've explored today as a potential cure, but it requires a pretty radical surgery. We have to abandon our oldest, most basic assumption that the universe is made of things and really consider, what if it's not? What if it's not a collection of things at all, but a symphony of pure motion?